Alright, in this video we're going to go through how we can have our normal DNA undergo a point mutation, and we're going to see what each point mutation may bring. This is going to be our original protein that we're going to refer back to. Just a couple reminders before we get started. The top strand is going to be our coding DNA, the bottom strand is going to be our mRNA, the amino end is where the start is, and the carboxyl end is where the stop is. This is just a diagram to help keep transversions and transitions clear in our mind, and then this is the ever so famous codon chart that we're all going to need. So a point mutation is relatively simple because you're only dealing with a single nucleotide, and you're not adding and you're not deleting anything. So your reading frame is not being shifted in either direction. So you could have a missense, a nonsense, a silent, or a read-through. You can pause the video here, read through those, see if they help clear anything out for you. So we can start first with missense, and that's going to change our original amino acid to a different one. So originally we had AGG coding for R, and we have changed this G to a T in our DNA, which is going to make our mRNA AGU coding for S. And this G to T transition, I shouldn't say transition, the change from G to T is a transversion. So moving on to nonsense, we're going to turn our original amino acid into a stop codon. Originally we had AAG giving us K. We've changed this A to a T, giving us UAG as mRNA. And if we look over here in our codon chart, we see UAG is one of the stop codons. So our protein is going to be shorter than the original. And then we have an A to T, which is a transversion. So silent, a little harder, I guess you could say, because you're getting the same amino acid. You're just changing one of the nucleotides. So originally we had GUC giving us V, except down here we still have V. So you're like, well, maybe it's the same. But we've changed this C to a G now. A C to a G is known as a transversion, and we can see on our chart down here that's going to code for the same amino acid. A read-through is where we have our stop codon, in this example UAA, code for an amino acid. So rather than ending here, we're now going to code all the way down through here until we reach another stop codon. So our protein is going to be way longer than our original. And we have changed this A to a T, and that's going to be a transversion. And these are the references.